What is an electrolytic capacitor? What is its structure? What are its features and applications? We're here today to answer all of these questions. Hello everyone, and welcome to the Boom Electronic channel. In this video, we're going to talk about electrolytic capacitors. Capacitors are among the most essential and widely used components in electronics. You can find them in almost all types of electronic circuits, industrial systems, and more. They store electrical energy similar to a battery, but unlike batteries, capacitors usually have lower capacity and can charge and discharge very quickly. Capacitors are generally divided into two main categories. First, polarized capacitors. These capacitors have positive and negative terminals. The positive charge builds up on the anode, and the negative charge on the cathode. This causes polarization in the dielectric material and aligns the electric charges accordingly. Second, non-polarized capacitors. These have a symmetrical structure, contain no electrolyte, and therefore have no polarity. They can be installed in either direction. Electrolytic capacitors are some of the most commonly used polarized capacitors, and in this video, we'll focus specifically on them. Electrolytic capacitors come in three main types, and we'll examine each. The first type is aluminum electrolytic capacitors. These are typically used in through-hole, dip, form in circuits. Their capacitance and maximum voltage rated on the body. A colored stripe marks the negative lead, and the positive lead is slightly longer to distinguish between the two. The structure includes the anode, cathode, separator layer, and the liquid dielectric. The anode is made from 99% pure aluminum with a layer of aluminum oxide that acts as the dielectric. The cathode is also made from 99% pure aluminum. The separator prevents direct contact between the anode and cathode and holds the liquid electrolyte in place. The thickness and purity of this separator are very important. Several of these layer combinations are placed together and held together and placed inside the capacitor. The second type is tantalum electrolytic capacitors. This capacitor is used in both dip and SMD forms in circuits. The capacitance of dip tantalum capacitors is written on them in microfarads and its withstand voltage is written on that capacitor with a positive sign. The positive leg of these capacitors is longer than the negative leg to indicate the difference between the legs. In SMD versions, the side with a stripe marks the positive terminal. Capacitance is represented with a 3-digit code, where the first 2 digits are the value and the third digit indicates the number of zeros to add. For example, a code of 104 means 100,000 picofarads or 100 nanofarads. The structure includes an anode made of tantalum, a dielectric made of tantalum oxide, and a cathode usually consisting of a solid electrolyte such as manganese dioxide. There's also a thin silver layer used as an electrode and a carbon layer that ensures good connection and distributes electric charge evenly. The third type is niobium electrolytic capacitors, which are mostly used in SMD form. These are designed to replace tantalum capacitors and have the same structure and characteristics, except they use niobium pentoxide as the dielectric material. Now that we've looked at the structure of electrolytic capacitors, let's explore their key features. The most important feature is their high capacitance, thanks to the use of electrolyte and dielectric materials. Another key feature is their compact size. Especially in SMD versions, they take up very little space, making them ideal for tightly packed circuits. A third advantage is their affordability. Aluminum electrolytic capacitors are inexpensive due to the simplicity of the materials and production processes. We hope you found this video helpful.